Hello and welcome to this short session on the JavaFX Canvas. My name is Simon Ritter and I work for Oracle as a technology evangelist. In JavaFX 2.2 we've introduced a new node type called Canvas. This is based very much on the HTML5 canvas, and if you've already used that you'll find that a lot of the concepts and the API to program it are very familiar. There's a reason for this, which is that we want to make it easy for people to take existing code that's been developed using HTML5 Canvas and move it into a JavaFX application. What we do is to create an area of our display which can be treated as an image, and then we can draw into that image and create whatever parts of the image that we require for our application. Once we've created the canvas, we treat it as a single fixed node. So we don't have to worry about a more complex scene graph being part of the image. It's simply an addressable area of pixels that we can manipulate. And we do that through a graphics context, which we'll talk about later. Unlike a group that we use in JavaFX, all of the nodes in that are live. In this we are talking about a single node. And so we can manipulate that as an image. From the point of view of the canvas class itself, it's actually very simple. What you have is an image that you want to be able to draw to, and that image is going to be made part of the scene graph in JavaFX. There's really only two properties that a canvas class has, and that's the width and the height of the canvas, so the area that you're actually going to be drawing onto. What you then need is a way of accessing that. And everything that you do in terms of manipulating the content of your canvas is done through the graphics context. So there's no scene graph to worry about. You simply have a set of APIs that are called through the graphics context, and all updates are handled by the rest of the system. Graphics context class is responsible for handling all of the draw calls to the canvas, and it does this through a buffer. So whenever you make a method call through the graphics context, it will update the buffer that's associated with the canvas and make changes to the image that's going to be displayed through the canvas. The graphics context is responsible also for pushing all the necessary parameters onto the buffer in order to make the updates that you want from your application code. The canvas only contains one graphics context and only contains one buffer, which is a logical way of organizing things. When you program and manipulate things using the graphics context, then you must issue all of the commands from a single thread. If you start trying to use multiple threads, you will run into things like race conditions and very unpredictable results. So make sure that you only use one thread to access the graphics context. Once you've created your canvas and you've got the graphics context associated with that, before you attach it to the scene graph, you can use any thread you like to manipulate the graphics context. Once you've connected your canvas to the scene graph, then you must make sure that all accesses to the graphics context are done through the JavaFX application thread. This is very important because if you don't do that, you may well find that it blocks the updates to the screen and things can become very unpredictable. The other thing that the graphics context allows us to do is to manage a stack of state objects. What this allows us to do is to record the state of the canvas at particular points in time, and then if we want to, we can go back to those previous states in the same order that we stored them. So we're treating it as a stack, so it's the last in, first out approach in terms of restoring the states. In terms of constructing graphical elements within our canvas, one of the primary ways that we can do that is using a path. And a path is basically a list of 0 or more subpaths. And each subpath consists of a list of 0 or more points. So positions within the canvas where we want to join things up with either straight or curved lines. If we want to create a closed path, then we use the closed path method, and that will create a closed path from the current point that we've defined to the first point that we defined. In terms of using this, we create a new path by saying begin path, call the begin path method, and then depending on how we want to create lines, we can use things like arc or arc2, we can use Bezier curve or quadratic curve to construct more complex curves, line2 for straight lines, and so on. We can also do things like filling a closed path with a particular color. We can check whether a point is within the path that we've defined, and we can also append a scalable vector graphics path to the path that we're defining. We also have some other basic graphics type methods. So we can do things like fill arc, fill oval for circles or ovals, fill polygon for an arbitrary number of points on a polygon, fill rect for rectangles, round rect for round cornered rectangles, and fill text for text. And we can apply transformations so that we can manipulate things in the way that we want to in terms of translations. We can rotate, we can scale, and so on. Since we are dealing with an image in terms of the pixels that we want to display on the screen, we may well want to put an actual image into our canvas. And so there's a utility method to be able to do that called drawImage. And since the canvas simply represents a set of pixels that we want to be able to use, if we want to get down to a very low level, we can actually manipulate the individual pixels of our canvas. From the graphics context, we can get a pixel writer, and the pixel writer will allow us to manipulate those individual pixels either by setting a value for it. We can set the values based on the alpha, red, green, and blue values, or we can use it setting a color explicitly. So let's move on to a short demo. So this is just a simple example of a canvas being used in a JavaFX application. So what we're doing here is we're creating a test frame where we're putting a background in, then we're creating a canvas, and we're giving an initial size of 200 by 200, and then we're moving it to a particular position. Now what we can do is we can actually apply some interesting things to this. So we're going to use a slider to control the size of the actual canvas. So we can modify the canvas size as it's being used. It has properties, those properties can be changed, so we can actually change the size of the canvas whilst we're using it. And so we simply create a slider which will control the width of the canvas. We add a listener to that, and we simply call the setWidth method on canvas with the new value. Similarly, we've got one for the horizontal size. We can do the same thing with horizontal size of the canvas, and we can change that as well. What I'm going to do is I'm also going to have a little ball that bounces around in my canvas, and I'm going to add a third slider which will simply enable me to change the color of that ball as it bounces around. So we have various labels and things there, and then essentially all the work that's happening is in the update canvas method. What we do here is we have the graphics context of our canvas. So we go back up here, we've got the graphics context that we're using here. We make that a global variable, and then when we get down to here and we update the canvas, we simply make all of our references through the graphics context. So we get the width and the height of the canvas because it may have changed, and then we draw a box around the outside of the canvas so we can see as it changes. And we're just basically looking at the a number of balls. So we set the fill color to be the color based on the slider, and we fill an oval of the correct size, and then we work out the new position of the ball. So we do various things to decide where it's going, and that's essentially what we need to be concerned with. So if I run this application, we'll actually see how this works. What's going to happen is we have our canvas and we have a little ball moving around in it. But what I can do now is I can say, okay, well, let's make the canvas bigger in the vertical and the horizontal, and you'll see that the ball now moves around in the right area. The size of the make that a little bit smaller, and that's all good. And then like I say, we can change the color that's being used within there, so we can move that all the way up. So it's red or it's blue. So we're using a slider for that. One thing that's worth noting here is that because we're using graphics context, we don't have the same concept of binding. So we can't use binding in the same way that we would if we were using the scene graph. And so that's basically just a small demonstration of the canvas class in action.